to the Truth in My Days podcast, where we defend the Word of God against the challenges of men.
Hi, I'm Dana Torst, and welcome to another episode of the Truth in My Days radio program. Today, I'm here with John Torst and Jason Chan as they discuss the important topic of creation and evolution. We are continuing from the previous episode. We hope you enjoy.
And these are orders of magnitude too short for the supposed age of the dinosaurs.
Right.
That was Nielsen Marsh's work. Alan Toff found the maximum time to complete disintegration. And complete means not one link left among the DNA letters. And that's complete. Remember, we found one segment that's 174 intact base pairs.
Right.
They said you would get complete disintegration at 25 degrees in 22,000 years. 15 degrees, 131,000 years. 5 degrees, 882,000 years. Even in the completely ludicrous scenario that the dinosaur bone was kept in deep freeze, minus 5 degrees Celsius for the entire time, the maximum possible length of time before all bonds had broken was 6.83 million years. Yes, 1/10 of the way back to the supposed age of this bone. So here's a huge problem for the evolutionists. There is no way that DNA could last the evolutionary time since the supposed extinction of the dinosaur bones. Mm-hmm. So there you go. How do you get around this? Well, you really can't. Here's the problem. Instead of going where the evidence leads, evolutionists naturally have to try to explain away the evidence. And they will have to try to find one of these previously unknown mechanisms that Dr. Schweitzer referred to, and they've made a couple of attempts. One of them is the claim that iron in the hemoglobin in the blood acts as a preservative, and that's basically preserved the soft tissues through all these tens of millions of years. Again, it's not possible. You will see this show up sometime on atheist websites, evolutionary propaganda, but it doesn't work. In this experiment, the researchers soaked ostrich bones in a concentrated solution of hemoglobin and found that the blood vessels in the ostrich bones were still recognizable after 2 years. And so they suggested that the iron in the hemoglobin acts as a preservative by cross-linking proteins to make them more resistant to decay, and by acting as an antioxidant. Sound reasonable?
Oh no, I'd have to look more into their exact methodology.
Exactly. On the surface, if you don't look and you don't look into it, it can sound plausible. And so evolutionists will say, okay, that's the answer, let's move on. But in fact, the explanation is bogus. First of all, the researchers used a concentrated solution of hemoglobin, which doesn't occur in real life.
I see.
On the contrary, where you have tissues that are rich in blood, they actually decay faster in real life than other tissues. They don't become more resistant to decay, they decay faster. The second problem is the idea that being recognizable after 2 years means they could last 68 million years is a non-starter.
Right, yeah.
Even if concentrated hemoglobin were as good a preservative as formaldehyde, and no one claims that it is, even formaldehyde only slows decay, it doesn't stop it. And with formaldehyde, we can look further than 2 years. Corpses that were embalmed with formaldehyde show noticeable decay in less than a century. So no, this iron is not going to stop decay across 68 million years. And the third problem with this supposed solution is that the concentrated hemoglobin probably acts as a pickling agent to maybe stop bacterial and enzymatic degradation. Again, you don't have that in real life, in nature. But even if it stops bacterial and enzymatic degradation, the dilute solutions in nature wouldn't have this effect, and under no circumstances does it stop the chemical and the thermodynamic breakdown. So this attempted solution doesn't work. The only other one I've heard of is the toast model. Does that one sound good?
Sounds yummy.
It does indeed. This was a study published in Nature Communications. The researchers here basically took some organic tissues, put it on a hot plate in the lab, and toasted it. And they found that it darkened in color. And when they examined it, they found that some proteins had become denatured and cross-linked to form polymers. So the same kind of thing that they claim about the iron in the hemoglobin, cross-linking things. And they found these spots were darkened. It's kind of a crusty, toasted layer. And they noticed that some of these fossils in which the soft tissues had been found also had dark spots on them. And so they posited that this sort of toasting had happened in the fossils, and these denatured cross-linked polymers then shielded the nearby proteins from microbes and even from chemical interactions, and that's why it lasted all this time. Does that one sound better than the iron model?
I mean, so far, maybe.
Sure. Again, it's one of these things, and they need to have it. They need to have things that sound plausible to the general public who will not look further, so they can just move on and assume the problem was solved, but it wasn't.
Okay.
This model itself has two fatal problems. First, they're assuming that the fossils' proteins and polymers had been lying in the ground with almost no decay for millions of years. They made no attempt to demonstrate that experimentally, because through the time, these polymers would also decay and stop offering protection. Basically, this comes down to saying it didn't decay because it didn't decay. The second problem is that some of the samples from the fossils were entirely soft tissues. They didn't have this crusty coating to protect them. Schweitzer's T-Rex bone had connective tissue that didn't have this kind of crusty coating to protect it. Armitage, remember that name, Armitage? Armitage and Anderson later published their description of a pliable sheet of soft tissue taken from a Triceratops horn. And that didn't have this kind of toast protection. Most notably, there's a Precambrian seafloor worm sheath that was found, written up in Journal of Paleontology in 2014. And this had no protection, no toasting. And the authors write, minerals have not replicated any part of the soft tissue, and the carbonaceous material of the wall is primary, which means it hasn't been replaced.
Okay.
So it's preserving the original layering of the wall, its texture and its fabrics. It is still flexible, as shown by its soft deformation. There's no dark, crusty toast material here. And yet this is supposed to be 551 million years old.
I see.
Remember, hard science has already ruled on this. These materials cannot last 551 million years. Under ideal conditions, they could last maybe 1/100th of this time. And these models don't address the issue of how the DNA lasted. So we'd have to say at this point, the soft tissues found in dinosaur bones, soft tissue fossils, prove beyond any doubt that the dinosaurs did not die out 65 million years ago. They didn't live millions of years ago, let alone tens of millions or hundreds of millions of years ago. These things lived in the time span of thousands at most. And that's what hard science shows. Theory of evolution and theory of deep time should be gone now. But as a famous doctor once said, the very powerful and the very stupid have one thing in common. They don't alter their views to fit the facts. They alter the facts to fit their views. Would you say you saw that happening here?
Yeah.
Absolutely. And here's interesting. Remember I told you to remember the name Armitage? Mark Armitage.
Mm-hmm.
What happened when he found the soft tissue in the Triceratops bone? He was working as a microscopist at the California State University at Northridge, CSUN. He had been hired to manage their electron and confocal microscope suite in the year 2010. He had published some 30 articles in scientific journals about his field of specialization. This is from Reporting God Reports from 2017. So he was hired in 2010, published some 30 articles in scientific journals. He's an expert in this.
30 is quite a bit.
30 is quite a bit, yes.
Yeah.
In May 2012, He went on a dinosaur dig in Montana. There he unearthed the largest Triceratops horn that had ever been found there. And he put this under the microscope and he found, as we said, unfossilized soft tissues. And he published it in February the next year, 2013, in a peer-reviewed scientific journal, Acta Histochemica, specializes in this very field, cell and tissue research. 2 weeks after he published it, he was fired. Without a job. A biology professor had come into his office and said, "We are not going to tolerate your religion in this department." Now, was there anything that had to do with religion in anything that happened here?
No, there's no mention of it at all.
He did good science, a well-qualified scientist, published in the scientific journals, took a sample, did observations on it the way you're supposed to do in real science, published it in a peer-reviewed journal, not a Christian journal, not a religious journal, well-respected journal of cell and tissue research. He gets fired for that. Because we're not going to tolerate your religion. You see, what they're admitting is that evolution is their religion. Atheism, which means evolution, is their religion. We're not going to tolerate any challenges to that. Now, in this case, Armitage sued, and CSUN fought that for a time, and then finally, when the courts were ruling in Armitage's favor, they had to settle out of court. Almost $400,000 in the year 2016. This kind of thing is very common. We'll see another example later, but it's very common. If you are employed in any field of science, if you start saying anything that sounds remotely like creationism, let alone young earth creationism, you're dead meat. Your career is toast. So when people ask, how come all the scientists go along with it? Well, it's your job or you go along with it. Right?
Thank you, everyone, for listening today. Unfortunately, we have run out of time, but please join us for the next part tomorrow. Same time and same place. If you enjoy our content and think this is important material, the best compliment you can pay is by sharing this with your friends and family. This helps us out a lot. Also, if you enjoyed today's program, please like, comment, share, and subscribe to this podcast. We would love to hear from you. Thank you for listening to the Truth in My Days podcast with John Torse. We would love to hear from you. Please feel free to share any questions or comments you may have. You can reach us on Facebook, Instagram, MeWe, and YouTube. Simply search Truth in My Days as one word. Again, Truth in My Days as one word, no spaces in between. And you can connect with us. You may also visit our website for more comprehensive material and to learn more about our ministry. Our website is truthinmydays.com. Thank you.